Well, good afternoon, everybody, and welcome to this special webinar that we're running here from Smart Vision Europe called Implementing Your Own ChatGPT, Developing a RAG Solution with IBM, WhatsOnX.ai. My name's Jarlath Quinn. I'm joined online today by my colleague, John McConnell. We'll be taking you through the demonstrations and the explanation of what the session is about. I'm also joined online today by my colleague Rachel Clinton. If you haven't joined any of these sessions before, we do a lot of webinar type sessions. Just be aware that the session is recorded, so you'll be able to listen to it afterwards. And there's some slideware here, so you'll be able to get a copy of the slides afterwards. We'll email out a link for you to download the materials. If you think it's particularly relevant for colleagues who are unable to attend today and you can get a few of them together, it may be possible for us to arrange a rerun of it so we can do another private version of it. The best thing to do is just drop us a line and ask us. With regard to asking questions, all the lines are muted, so we can't hear you, but we do ask you to use the chat panel. And if we run out of time, we'll follow up with you in the same sense. If there are questions that occur to you afterwards, after the session's ended, please do email us and we'll be happy to address those. My colleague Rachel and John will also be just monitoring the chat panel as we're going along. I'm going to start off today and just introduce who Smart Vision Europe are to you. Again, if you haven't seen any of these sessions before, you should be aware that we are a gold accredited partner to IBM as well as a partner to a company called Predictive Solutions and Data Robot, and we specialize in statistics and advanced analytics and AI technologies. We also, you should be aware, work with open source technologies such as R and Python and Spark. And we're a relatively small organization. We've got a relatively small team of people, but we've all got very deep and long experience of working in the advanced analytics industry for most of us, about the past 20 to 30 years, something like that. And that means we've got a lot of experience of applying data science and statistics and AI and machine learning type applications across multiple sectors and multiple applications within those sectors, both within the private sector and the not-for-profit sector. This session, we're going to be looking at what is called a RAG solution, a retrieval augmented generative AI solution. And we're really using it as a way to explain how we developed our own RAG solution called ChatSPSS, which we're launching and making available to all comers. And we thought that would be a good way to introduce this concept, this type of technology, with a view to explaining and educating people on how they could do the same thing themselves. So we'll be talking about the key elements of a RAG solution, and then I'll start doing some demonstrations. I'll demonstrate ChatSPSS if you haven't seen that already, which is really the end point of our project in RAG, in working with a RAG solution. And then I'm going to open up WatsonX.ai and show you how you can get started yourself with your own information, your own data to develop your own type of solution. Firstly, with what's known as the prompt lab. And then secondly, running what are called auto AI experiments, where you can actually get it to try out many different settings, many different model types of many different parameters, and then choose the best one based upon a pre-specified criterion that you have. That's called the auto AI RAG. And then my friend, my colleague John's going to talk about deploying RAG models, how we actually got from developing a model within WatsonX.ai and pushing that to the outside world and using it to create the Chat SPSS application, which you can have a look at and play around with yourselves. So I do hope you find that interesting. Let's just get started with what is a RAG solution, what we're actually talking about, because most people are aware of of things like Claude and Copilot, and of course, and these chat bots that are out there available. Most people played around with them, and a RAG solution is very, very closely related to that, of course, because it's working with very much the same technology. A RAG solution is called RAG because it stands for Retrieval Augmented Generation, and it combines generative AI with a retrieval system that allowing a model to pull relevant facts and context from a database or a corpus of document or unstructured data before generating an answer. So you can basically point it at a pile of data or a pile of documents and create a solution very like ChatGPT or something like that, which would allow you to query it and effectively get much deeper understanding of what's actually happening within that data. So it helps reduce hallucinations by grounding the AI responses in up-to-date verifiable data. You hear this term grounding a lot. That means basically using your data that you've given it rather than exposing it to the wider world of data out there, which may not be verifiable, and also exposing your own data to the wider world, which you may do, of course, if you're uploading large amounts of your own data to an open public chatbot. You might not want to do that because, of course, there are issues around security and there are issues around the accuracy of the data and the responses you might get. And it generally, of course, makes it easy, therefore, to query the huge collections of data like reports or logs with a single prompt, just in the same way that you might ask a Copilot or something like that a question. And as a result of that, of course, it's going to improve efficiency and accuracy and transparency in a secure setting. So people develop RAG solutions because they want to be able to query and manage the knowledge of their own collection of data that's out there. And we want to build that, break that down into more detail. Well, basically, what it offers an organization, rather than simply using something like ChatGPT or something like Copilot, where you might want to upload some not very important documents on an ad hoc basis and have it query it for you or have it summarize them for you. Here you might have a large collection of data, might be structured or unstructured, and here you can impose a lot of control over it, a lot of control and compliance over the data that's included, and make sure that's relevant, make sure it's accurate, and the user control who can access it, of course, because you can make it private. You can have a degree of control over the quality of the results that you're getting because you can test them and check them and make sure that they're accurate, and of course restrict it to a universe of knowledge that you own, that you have control. You can play around with different types of language models called large language models, and you can swap them and change the parameters very easily. You can experiment with it quite easily, something which you wouldn't be able to do, of course, if you're using a generic, publicly available chatbot. And you can ensure that the data is relevant, the responses are relevant and up to date. You can control versioning, and you make sure it's current. And you can even integrate and automate this with your own systems, whether it be a CRM system or workforce management system or a HR system or a research system. So in a nutshell, building your own RAG affords organizations the ability to make sure that the responses are accurate, that they're compliant, that they're current, and that they have control over the entire solution itself. And that's one of the reasons why these are very compelling types of technologies for organizations. We're going to have a look at how we can actually do that. So real world applications of RAG solutions would be things like, we've seen this sort of stuff before, but customer support, where you have chatbots that provide accurate context-rich responses based upon FAQs or product guides or technical support tickets. Or healthcare and life sciences, where you have a corpus or a large collection of data that's related to medical literature, research, might be patient records, and without having to actually query them or go through a query tool, filter, or manually sift through them, you can actually use a conversational query tool like you would with these chatbots to try to interrogate that and get it to link information together for you. Legal and compliance, so helping lawyers or compliance officers find relevant case law, regulations, or contractual clauses much more efficiently. In financial services, it can help with summarizing relevant regulations or giving you market reports to assist analysts and advisors. And in e-commerce and retail, it can enhance product recommendation systems or answer customer questions using information drawn from product catalogs and reviews. And in government policy, allowing things like policymakers and analysts to extract relevant insights from large archives of policy documents, demographic information, laws, or public records. So this is really just the obvious types of applications for RAG solutions, but really any organization that has particularly a lot of unstructured data, and then maybe has in the past used some sort of internal portal or intranet or some knowledge base or something like that to try to manage it. A RAG solution is often a much more efficient, easy way for users to query that data and to get much richer responses and summaries and links between concepts than using traditional means. So the key elements of a RAG solution, what actually makes it up? Well, we're really talking about these elements because you will see when we start doing demonstrations in the IBM Watson X world, you'll see it referring to some of these elements, and it's important for us to actually try to describe what they are so that it's not too obscure. But one of the terms you'll see is the term embedding model, and an embedding model, basically instead of storing raw text that you would in a database, what an embedding model does, it's a language model, is it basically converts raw text and documents and paragraphs and sentences into something called vectors. And vectors are basically numerical representations of that data. They're almost like a coordinate system. They look like a number of fields in the data set with numbers attached to them. And these vectors, for example, will do things like tell you how closely related one concept is to another. So the coordinates or the vector values, say, for a term like king, would be similar to the coordinates or vector values for a term like queen or royalty or something like that. It knows that they're semantically linked to one another. So this is one of the ways in which the system starts to break down the raw data and make sense of it by using an embedding model to convert it to these numerical vectors. And after it's done that, it creates a database. So you'll see the embedding model creating a database, which basically converts these into vectors. These are stored in a vector database instead of plain text. And you can think of the vector database really as a kind of like a GPS coordinate system. Instead of longitude, latitude, it's hundreds of numbers that describe the semantic position of the text fragment. So the embedding model is the method by which it creates these vectors, and the vector database is the resulting collection of values that represent the relationships between each of the concepts in the many documents or data that you've uploaded. And then the next element is what's called the large language model, the LLM, bearing in mind that the embedding model itself is also a kind of language model as well. And the LLM takes the query that you submit as a user to the vector database, and it basically converts it into a meaningful response. So it gives you a meaningful response. You could ask it for a detailed response. You could ask for, a layman's approach. You could ask it to summarize it into 3 points. That's what the large language model is doing. It's retrieving the data and presenting it back to you in a way that hopefully addresses the initial query correctly, summarizes it in the right amount of detail, and gives you the correct references to that, and allows you to basically converse with it. So these three elements you'll see referred to are the embedding model, which you can think of as the thing that creates the coordinates, the vector DB, which is very much the sort of map of all of the data that's been produced, and the LLM at the end, which is the GPS system that navigates the map. Okay, so when we come to querying a vector database, when we actually use something like ChatGPT or something like that, or use a really simple RAG solution, what we're doing is we're asking a question, and that's being submitted to something called a retriever. And again, I'm mentioning this mainly because you may see reference to the retriever in some of the documentation and in some of the interfaces that we're going to show later on. But the retriever is really just the query system, and the retriever goes off and queries the vector database, effectively, this map, if you like. It then collects the relevant information. So if the retrieval settings are good, and it's a good retriever, it's got the right parameters in it, it should find the relevant information, of course. It then passes that along with the original question to the large language model, which then presents back hopefully a meaningful, useful response, or useful answer. And each of these elements are things which we can, to a degree, play around with when we're designing our RAG solution. To a large degree, this can be automated. So you can have the Watson AI basically do it for you, but it allows you, a lot of control. You can try out different language models. You can try out, different retrieval settings, and see the effects of those. When you can even run little experiments where it can automatically try different settings for you, and then you can choose the answers that you like the best, and therefore the model that you like the best as a result of that. So the first thing I'm going to talk about is our summer project, which was ChatSPSS, which is our RAG system which we've made available to the outside world. And the reason we did it was because we wanted to learn about Watson X AI more deeply, and its RAG capabilities. We've actually already used Watson X AI for other projects. It's a platform with many data science and machine learning capabilities associated with it. So we might use it for document classification. We might use it for a lot of data science type projects. If you're familiar with SPSS Modeler, for example, well, Watson X AI has a version of SPSS Modeler which effectively works on the cloud. So we would use that as part of the Watson X AI platform. So the RAG capabilities are really just one element within it. That's the point we want to make here. And we wanted to learn about that. And we thought, well, let's pick an area where we actually already have a lot of subject matter expertise and a lot of available data. And the area of subject matter expertise that we have as a company is very much around SPSS, because we worked for SPSS. We've all pretty much worked for SPSS at some point in the past, and we've often worked in a technical capacity. So we know all of the documentation around that, of which there's quite a lot of documentation, a lot of PDFs, a lot of data out there. And we thought, well, if we build a RAG solution around that, we can use it as a little example, a little demonstrator to people when they say, well, show us an example of the sorts of things you can do with this. And the other thing we thought that was, well, if this works successfully, we could just deploy it to the wider community of SPSS users out there for free. They wouldn't actually have to pay a subscription or anything like that. They could just, if they want to be able to query this corpus of SPSS documents, then why don't we develop our own RAG solution to do that? And this is the initial version one of our ChatSPSS RAG solution is based on a collection of 20 PDF documents covering SPSS statistics base plus assorted add-on modules and admin docs. Basically, as you can see, there's a lot of docs around just SPSS, because SPSS has a lot of modules. There's the aspects of actually working with the software itself, the administration of the software. But there's also a lot of concepts around statistics and advanced statistics and all these different statistical methods, as well as things like licensing, etc. So as a result of that, there's a lot of individual PDF documents. Some of them vary in size, some of them quite small, some of them much larger. There's at least 3 documents that are basically just referring to the base, what we call the base of SPSS, just the basic sort of implementation of it. And there's other documents that relate to, integration of languages, that relate to graphics processing, relate to syntax, which we didn't include in this initial version, but which we could include in a forthcoming version. That's certainly the ambition. So what ChatSPSS looks like is when we deployed it back out onto the world, we deployed it out with its own little URL, which is chatspss.com. And it looks very like a chatbot, as you expect. So you could basically go and query that and type in a query and get a response as you would expect using something like Copilot or ChatGPT. So if I just jump out, if I just skip out of here and go to my browser and go to ChatSPSS here, and you can see I've logged in already, and it's just saying, how can I help? And I could just start off and ask like a really simple question, such as, where do I find frequencies, or frequency tables? Really simple question like that. And it goes off and thinks about it, just as you would expect when you're dealing with a chat bot. It goes off, and it's now, of course, The retriever's gone to the database, and it said, okay, to find the frequency tables in IBM SPSS statistics, you can use the frequencies procedure. This is where you can find it and analyze descriptive statistics. It's even giving me a little bit of syntax there of an example associated with that. It's also showing me which documents it's retrieved from that point. I can actually switch it to dark mode or light mode. You can see I can add a new composition at this point to change the subject, and I can export the results of that out as a PDF if I so wish. So very simple, very obvious to work with. Here's some examples I'd already kind of created. So this is one I asked it the other day because I literally I didn't know how to do this. I wasn't sure what the difference was between the output management function and a procedure called output modify. And rather than using the help system, I just thought, well, I'll just ask ChatSPSS and see if it knows. And it went away, and it, of course, once again, submits that to the retriever, which then puts that out to the vector database. And it gave me a pretty good response, very similar to this one, where it basically says, well, look, the OMS is focused on capturing and routing output to different destinations, while output modify is focused on customizing the appearance of the viewer. That's all very useful to me. And because I'm having a conversation here, I could say, well, okay, that's great. Show me an example without telling it, show me an example of the difference between OMS and output modify. It will understand it's part of a conversation. So it goes off, and the retriever, once it goes off and looks at the vector database, submitting the context around the query, and it says, okay, here's an example. And it gives me an example of, it allows you to capture and save output from a statistical procedures for further analysis and reporting if you want to use the OMS function. Whereas this one, the output modify function is used to modify the appearance and output of the objects in the viewer. It allows you to customize the display of the tables and charts and other outputs. So it's showing me a couple of examples here which are quite useful, and key differences between them as well. And I could continue to submit these queries to my heart's content at this stage. So now I want to talk about how we got there. I mean, what we actually did to get there, and how we developed this solution. So if I just come back to my slideware here, you should be aware that you can actually sign up for ChatSPSS yourself. And this isn't refreshing. Hold on a second, see if this will refresh. So you can't sign up to ChatSPSS yourself, and you should get a link in one of the mails emails that comes out to us. But if I just show you alternatively, you can go on to our website, the services section there, and say Meet ChatSPSS, your AI-powered SPSS tutor, and just register for it yourself. Just sign up for it yourself. It's free, and it will be querying those SPSS resources if you're an SPSS user, of course. Bearing in mind that we will be releasing at some point in the future a version 2 of it where we add more data to it at that point. So how did we get there? Well, we started off using the Watson X platform, and we started using something called Prompt Lab. So Prompt Lab is a good start point. And you can see here it says, this is a place where we can create and test a basic RAG model. When you go into Watson X AI, you can see it says ground gen AI with vectorized documents. A good place to start. Grounding generative AI. Grounding means giving it a collection of your own documents so that the responses are grounded within the context of those documents. You can see next door that it says build machine learning or RAG solutions automatically. We'll coming on to that later. But here under the prompt lab, we can design, test, and refine prompts against a library of IBM hosted foundation models. So IBM's actually got more than one large language model. You can test out one against the other. It already has them. You just literally just pick them. And it allows you to experiment across these different models and different applications. As you'll see, it actually does more than just RAG applications. It will do stuff like Q&A or classification of text, and has some ready-made examples of adjustable parameters. Here you can try out different prompts, compare outputs, and lock in effective settings without writing code. So if I just jump out to the IBM universe here. I'm just going to go to the project. So here are loads of projects within IBM Watson X that I have. Here's the one that I'm working on, the Smart Vision RAG project. If I click on that, it's logged me out, of course, because I've been talking away. But let me just log in. Okay, so here's the RAG project. You can see that this project is made up of a number of assets. The assets include things like the data that I have uploaded here. So I look at the data assets here. You can see that, look, most of these, let's see, where's the data assets? Here we go. Click here, data assets. These are all PDFs. These are the PDFs I've uploaded. I've just literally uploaded by clicking upload and selecting a bunch of documents. So I'm going to work with those. If I wanted to create a new asset here using the prompt lab, I'm just going to click on build machine learning, or I'm actually going to click on ground Gen I with vectorized documents. Click on that. I'm going to give it a little name. I'm going to call it a webinar example. And I'm going to select from my uploaded project a few, not all of them, but just a few of them. So I'll just go down to the bottom here. I'll say, let's pick the stuff from the core system here. The brief guide, the core system, and SPSS base. This is all related just to the basic implementation of SPSS. And if I click create at that point, what it's now doing, of course, is it's building the vector database. It's turning all of these documents and all of the concepts and information into those documents into a series of numerical values and multiple fields that show how they're related to each other as a coordinate system. And once it's done that, I'll be able to query that vector database. You can see here the vector store is simply in memory at this stage. I can add sample questions. So sample questions are like default questions. I am actually going to add these. I've got some of these sample questions. So I'm going to say add sample question number one. And I'm going to copy one which says, what does automatic recode do? And the reason I'm doing that is because I'm going to play around with the settings. And I want to see how changing the settings affects the questions, or the answers to the questions that I'm giving it. And I want to make sure, of course, I'm submitting exactly the same question each time. So these are like my three default. You could think of them as like FAQs. You could add these in. Say add that point. And then I can open in Prompt Lab, just down here very subtly in the corner. I can say open in Prompt Lab. And there is the database. There's the vector database down there, the webinar example. And here are my basic questions that I'm asking it. What does automatic recode do? How can I read tables from an external database? And what's the difference between Pearson's correlation and Spearman's? Note along the side here that we have other types of applications. Look, that it's not just RAG, it's summarization, meeting transcript summaries, some pre-built applications here, a scenario classification, feedback classification, claim processing generation, questions and answers about an article, questions about insurance, code generation, code translation. So there are some sort of pre-built templates here. We're happy to stick with this one. And I could start off just by saying, what does automatic recode do? What that's doing is it's basically giving me a little example of what automatic recode does, and it's using a large language model up here. It's actually using one called Maverick. I quite like that one. It's not always the default. The default, as you can see, I can just switch from one large language model here, which is the thing which is assembling the answer from the retriever. But I think the default is normally just this Granite 8 billion component instruction, the 8 billion coefficients in it. And if I run that, it tends to give much terser answer. Yeah, so you can see that's the effect of choosing one language model over another. So I could play around with these and say, well, okay, let's try this. And what about that Llama 11 billion element language model? What does automatic recode do? It's giving me it's summarizing and giving me the responses in different ways. So, and even within here, I can play around with model parameters. You could clear the chat here and say, okay, what about temperature here? What's that do? Well, if I don't know what that is, it says What sampling temperature to use? Higher values like zero point 0.8 will make the output more random, while lower values like zero point 0.2 will make it more focused. So I could play around with this and just say, okay, let's try that. And then just run that again and compare it to the previous one. Yeah, it looked like it's as I expected. It's kind of creating junk. It's not being assembled together properly. The large language model hasn't really been able to do its job properly, and it's just spewing out this random information, if you like, which is very hard to make sense of. So, you can change these parameter values. You might want to do so with caution to a certain degree. But you can do that, and you can play around with these values if you want to really get into the depth of that and play with them. If I went back to my Maverick model here that I had earlier on, I could say, what's the difference between Pearson's correlation and Spearman's? You can see it's giving me an answer. Let me ask a question which I don't think it knows the answer to. Um, I don't think it knows the answer to what is a CRT decision tree. And the reason I don't think it knows the answer to that question is because that's not part of the documents which I uploaded. They're part of the decision tree module, and I didn't include them. So I try that. Let's see what it does. It says basically it doesn't explicitly mention the CRT documents. I'm sorry, I've still got my model parameters here, somewhat producing somewhat random output. So I might want to change that back down to model temperature, back down to a much more conservative value, and try it again. So here it is. I could say, okay, let's try that question again. What is CRT3? It says I can't answer that document. It tries to make a guess as to what it might be. It sees some references to tree, but it's pretty explicit, saying I don't know what that is. And depending on the language model that you're using, sometimes it will just be quite blunt and say I don't know what that is, which is correct as the context doesn't provide information about CRT decision tree. Now, each of these models here have their own basic prompt that's been used. So if I look at the system prompt, these are the instructions to the model that the system has. It's telling it what to do. Here we have this Granite model. It says, look, you're an AI language model developed by IBM in 2024. You should be cautious. You should follow instructions. You're helpful and harmless. When generating responses, prioritize correctness. There's loads of these instructions about basically telling it off and telling it to make sure it's honest and true. But this is generic. It doesn't know that I'm actually given a collection of documents that relate to a system called SPSS. So as a result of that, I could go to, if I went back to the Maverick one here, for example, I could go and ask it a question like, what's the difference between Pearson's correlation and Spearman's correlation? It gives me a good answer, but I could give it my own prompt, and I've got a prompt here. Basically, it says things like, um, always base your answers strictly on the retrieved documents. If the answer is not explicitly or clearly stated in documents, say so. Do not guess or generalize. Don't answer questions using Python or other coding language. Instead, try to use SPSS syntax. If appropriate to the context of the question, try to show an example when you're giving an answer. So I'm telling it now that what the data is and what type of assistant it should be. And here I can see that its system prompt has a lot of information around the formatting. Um, and I could actually just copy and paste my prompt into that and hit save and then ask the question again, what's the difference between Pearson's and Spearman's, and see if it makes a difference. And what we see right away is it's actually giving me some examples here. It says potentially harmful context removed. I'm not quite sure why it's doing that, but if we asked it to remove any data like that, it will do that. If I run it again, of course, it will regenerate that response because there's always a random aspect to it. If I ask it to do the automatic recode example that we saw earlier on, it gives me an example, which it didn't do beforehand, because that's something I've added to the instructions to the prompt. So this is showing me that I can play around with how I query this vector database. It's showing me that there are multiple language models to use. It's showing me that there are lots of parameters out here to play around with. And it really, if I was just using this, I guess I would eventually come up with a set of answers or a set of settings, parameters that I thought were useful, and I thought, okay, this is a good enough model. I'll go with this. But there's always a possibility, of course, that there were other things I didn't consider because I didn't have time to do that. And as a result of that, I might want to take, a slightly different approach to this and use another method, um, which allows me to maybe be a bit more systematic in trying to find the optimal settings for our solution. And that leads me to the auto AI RAG approach. So the auto AI RAG approach is doing very much a similar thing to what we were doing there for the prompt lab, where we create a vector database, etc. But this time we're setting up experiments, if you like, that try out lots of parameter settings. That means trying different embedding models. Chunking refers to how it splits the data up, whether it splits it up. Semantic chunking, for example, splits things up according to the subject matter, according to paying attention to the headings, which is quite useful for this type of set of documents where there are a lot of headings and everything's kind of broken into topics. You can try different LLMs, you try different parameters, and it ranks them according to how they performed. Now, one way to do this is to compare how each model scored against a perfect set of example questions and answers. And that perfect set of questions and answers is submitted as part of an evaluation file. And any of the resultant models can then be directly deployed to the outside world and compared against each other in terms of how they answered the questions in the evaluation file. So it's kind of like our set of FAQs. Now, this is an example of what the evaluation file looks like. It's actually a JSON file, and it looks a bit system, it looks a bit kind of code heavy to begin with, but actually it's not. It starts with a question. Here we have the question: when you import data and define a variable width string field, what is the maximum width you're allowed to set? And then it gives a correct answer. A variable width string field can be as wide as 32,767 bytes, and it tells it where that is in the document. Now, there's a bit of formatting here. What you can actually do is just do this if you wanted to type it out in a text editor, like I've got here. I've just got Notepad. But alternatively, you could come up with your own questions and answers, and you could submit it to something like ChatGPT and ask it to create this file for you, because it'll actually give you within the platform itself. It'll give you an example of what the structure of the file is. So in my case, I simply said to ChatGPT, here's some documents. Just see if you can cherry pick out 20 good questions for me and put them into this formatting for me so I can download them as a JSON file. I got it to do it for me. And then I simply cherry picked some of the questions out. I thought that's a good one. And I added my own in, and I asked ChatGPT to reformat them. And eventually I ended up with a nice formatted JSON file here, just like this, basically without me having to type really much in at all, without me having to worry too much about missing spaces or indentations being incorrect or commas. So that was a kind of nice cheat, a nice way around it to use another AI system to help you develop your own evaluation file. So when it comes to evaluating the RAG model, we're comparing it against things like the evaluation file. And it turns out there's more than one way to do that. There's more than one metric that one can use. One metric is called answer faithfulness. This measures whether or not the generated answer is consistent with providing the retrieved context. It minimizes the likelihood of the response, including information that wasn't in the source document. So it minimizes the likelihood of having hallucinations, where it basically starts to make up answers. Answer correctness is a different metric. This evaluates the factual correctness of the information presented in the final answer. And while faithfulness links the answer to the context, correctness verifies the answer against known facts in the documents and the evaluation file. Here, the focus is on enhanced accuracy and reliability. And the third metric is called context correctness. This is actually a retrieval quality metric. It's really looking at the retriever. And in auto AI RAG, context correctness shows how well the retriever performed in pulling the right chunks of context compared to the benchmark. As such, it's evaluating the retriever, not the generated answer. So in practical terms, how do we choose one metric over the other? Well, if you want to minimize hallucinations, then answer faithfulness is probably a good optimum to ask for, to ask it to maximize answer faithfulness. But watch correctness as a secondary metric. If you need to match exact answers, for example, in things like safety and compliance applications, you also might want to minimize hallucinations, but you might really also want to optimize answer correctness. And you can use the context correctness if you want to debug the retriever itself, if you want to play around with the parameters such as chunking or embedding or retrieval and need tuning. And you can use the context correctness to compare one set of answers against another. Okay, so what does this look like when we submit our document? We say, okay, rerun it again, but try out many different models and rank them in terms of how they performed against our evaluation document. Well, what you'll see is when I run this, is it starts the experiment process and it says, okay, I'm going to read the initial document collection. I'm going to read the evaluation data. I'm going to then start pre-processing that, turning it into a vector, and then going to choose a model. And eventually it works its way through this series of steps until eventually it produces a model at the end. Here's one model. This is the llama model, 70 billion parameter model, which we could then test and check. And it keeps going as it adds models one after another to it. And eventually you can get it produce like 20, 18, 20 models if you like, and then compare them. You can see that in this case, this is being ranked by answer correctness. Okay, so let's just jump out and I'll quickly show you how we get there when we're in the IBM Watson X.AI platform. So if I go back to my my project here, I've got my SB project. You can see that down here, I've actually already done many different experiments, auto AI experiments in the past. And I can click on one. This is one I've done in the past on the 30th of June, 25th of June. So I'll just click on that. And you can see here, I've actually asked it to build, and it has successfully built 18 different models. So there's 18 different models. And in this case, it's ranking them in order of answer correctness. So that was the metric I asked it to rank it by, answer correctness. I could play around with this. I could actually get it to rerun it, and I'd show you how this model was configured or how this experiment was configured, because I can click on reconfigure. If I click on reconfigure here, I can reconfigure the experiment. And here you can see I have my list of data, my PDFs. I've used all of these PDFs, these 20 different PDFs I mentioned earlier on, but I've also got my evaluation file, which I've just pointed it to the evaluation file. I've got, it's going to use 4 different, what it calls foundation models. These are LLM models, language models, and 4 different embedding models. And I can click on the experiment settings, and I can go into the experiment settings and say, look, I want you to maximize, let's try for answer faithfulness. There's also a model here which says answer faithfulness AI. If I hover over that, it says the accuracy of the generated response to the retrieved text is judged by the large language model rather than just by the evaluation file. And if I look down through here, there's a lot of stuff it's automatically doing, but I can play around with chunking. I can play around with which models it's going to use when it's choosing an LLM to present the data back to us. And I can edit the system prompt. So you can see here for each of these models here, I've pasted in, you are an expert assistant for IBM SPSS statistics. You provide safe, accurate, blah, blah, blah. And I've given it the instructions. So I've overwritten the default. I've also got additional information here with regard to the indexing, the embedding model. That's the thing that creates the vector database. And I could say, well, don't bother using that one, or that's not important. There's a lot of different settings, a lot of different parameters. I can have it try out or have it choose automatically for me. And if I hit save or cancel at this stage, I could then run that experiment again, and it would start running it as a new version of that experiment in the background. And what we'd see is if we sat here and waited for a while, we'd see it building up this series of models. But while it's doing that in the background, I'm going to jump to one I've already produced more recently. So I come back here to auto AI experiments list here. We can see as this just updates, it'll say status pending because it's running. And I can go to this one here, this auto AI experiment in the 26th of September or 23rd of September. And here's another one. So let's have a look at the models themselves this time. So here are the models. You can see the best one that's the one that's chosen here is it's asking them to rank them in terms of answer faithfulness. You can actually use a hybrid ranking strategy where you're not choosing one criteria over the other. You can actually say, I want you to choose to take a kind of hybrid approach. If you use a Milvus database to store the models in. And here I can see all of these different models and their ranking scores being added here. And if I pick on one, I'll just pick on one like this granite model here. That's the pattern 16. That's the model 16. I can see which one's the best one. It's saying, look, answer correctness, not very good, 0.46, 46%. Answer faithfulness, 93%. Context correctness, 85%. And I can go down through this and I can see the prompt I've added to it. And I can pick a question like, let's see, oh, there you go. How does Cox regression and IBM SPSS advanced statistics handle censored survival data and what assumptions does it make? That's a question I've answered. Here's the answer it is. Here's the expected answer, so I can compare it against the expected answer. Here are the scores for that against the three dimensions, one against the other. So I can play with this. I can really start to drill down into this and look at all these and compare the answers against the perfect answers. I can also click up here and say, okay, look, let's look at the importance, which aspects were the most important with regard to driving the scores, with the highest scores. Well, the foundation model was very, very important. The LLM, the window size, that's the size of the chunking that's taking. And I can even do a pattern comparison where I'm comparing all of these 18 different patterns, these 18 different models against one another in terms of context correctness, answer faithfulness. Or I can come back to the experiment summary here. I can add on leaderboard features here. I can ask it to add in context correctness at this stage. And I can scroll down and just look for a different model here. So you can see I've talked about in the past the Maverick model. So I could click pattern 3 here. Maverick models, and I could say, okay, look, let's compare that against the best one. So which is pattern 16. Say compare pattern. And I can see them side by side. So I can see the answers that they're giving side by side. Sometimes just using the metric of one over the other. You can see where this one's better. This one's better at this dimension. This one's better at this dimension. And you can see the answers again. So it's a really good way for me to compare one against the other. And it's also a way for me to try out many different models at the same time as an experiment and then choose the best one. And in terms of choosing the best one, well, if I picked one of these models, I could simply say save as, and I could deploy it. And deploying it, of course, is where I surface it to the real world. And on that note, I'm going to pass over to my colleague, John, who's going to talk to you about deployment. There are some questions. Are there some questions as we're going along just before we pass it over to John? Is there anything here that we need to address at this stage? All right.
Oh,
Okay. I see
sorry,
this.
on
It's
mute.
just
I'm on mute. No, it's just
yeah.
me on the chat. Don't worry.
Okay. Fine. Okay. Fine. That's fine. Okay. I will drive the slides, John, for you. This is deploying RAG models.
Thanks, Charles. Can you hear me?
Yes, I can.
Okay, thank you. So we're still inside Watson X, and this is the next stage. So this is where we've just been through the process where that Jarlath went through, where we decided after the auto AI, or perhaps we got to this point from building our own model from the ground up using Prompt Lab, where we have a model that we think is good and we want to share it out. We want other people to have access to it and to use it. So this is the Watson page that we come to make it available, to deploy it effectively. And what you can see on the right-hand side under Define Details is we have two choices. We can deploy as a notebook or as an AI service. Now, a notebook And again, I'm sure some of you on the call are familiar with Python, whether you use Python or whether you're familiar with how Python is structured and used. But notebook effectively means a Python notebook. So if we were to select notebook, what Watson would do would be to wrap everything that Jarlath just sort of stepped through the different forms and the interfaces and the model he selected into a single Python notebook. And that encapsulates everything. And the idea is you can just take that as an entity, take it somewhere and use it. And then you've effectively got everything that we just did, including access to the LLM, the vector database access, and all of that wrapped up in one piece of code. And that's an important point because at this moment we are going more towards code. But the good news is we didn't have to write that code. Watson gives it to us. The option that we've used with ChatGPT, Giles, if you just click the next slide, please, is to go for the AI service route. So the difference with the AI service is it's still fundamentally Python code, but it is a service that still sits inside the IBM cloud and just waits. It's a service that waits to be called, waits to be used. So it's there and it's ready so that it can run all the stuff that Java just built, but on demand, if you like. So it can be called and questions and prompts can be given to it from anywhere, whether that's inside IBM Cloud, whether that's potentially your own PC, your desktop, or whether it's inside another cloud system or inside your own internal network or wherever it is. You know, there's a structure now where we can make this available wherever we want to through a call to the service and a structure that gives us the ability to call into the service. So this is the approach that we've taken with ChatSPSS. We've created this service. So we just like to click the next. So once we say, right, we want to create the service, the same screens we were looking at with Jarlath, pause while the service is created. And typically, you know, I think at the beginning we looked at maybe 20, 30 documents. You know, this at that level will take, I guess, you know, 3 or 4 minutes, and the service gets created and it's then ready, it's resting, it's sitting there inside the IBM cloud. Next slide, please, John. Now, this is where it starts to get, and I think one of the important points to make, and Jarlath used the phrase without writing code earlier. And one of the things I think that we really like about the way that all of this is implemented within the IBM platform is, you know, the JSON apart, and we looked at the JSON, and even then it wasn't particularly technical or codey, and it's very easy to create using ChatGPT, for example. You know, we didn't use a line of code. So in the modern vernacular, this is no code or low code up to this point. And it also means, and I know there's a lot of SPSS users on this call, that it sort of follows the style of SPSS itself, in the sense that the SPSS allows us to run advanced statistics through user interfaces, sometimes syntax, but makes it very easy and very user-friendly so that statisticians and subject matter experts can do that creation part, you know, that we can run the analysis. And that's what this role is. So the role up until now has been, you know, Jarlath as a subject matter expert has been able to build these advanced models, but hasn't written any code. This is the point at which we probably do need to start to find somebody who can write code to make the deployed version of this available to a broader audience, you know, inside our organizations, let's say, typically. So this is the detail that they need to translate from what we do as subject matter experts, building the models, into putting it out there in some way, probably through like a web interface or something, or through another application. And actually, it's the detail in the middle there. There's public endpoints. So, you know, everybody talks about APIs these days. APIs are the ways that systems talk to each other. This defines the API between Watson X and whatever it is we use to provide that chat capability to our users, to our internal audience. If you could click next. And this looks very, very techy. This was our way of implementing ChatSPSS. Um, what's important here, I guess, is we didn't do it within IBM. On the left-hand side, you see we've got the Watson X cloud, which is where everything we've looked at until now sits, including the LLM, including the AI service. But this is the architecture that we use, so we put it on Amazon. And one of the interesting things, I guess, about this new world of LLMs and clouds and so on is that they all kind of collaborate together. So even though we build the models within Watson, we can deploy them on Amazon or Microsoft Azure or on Google, because they all kind of have a way of talking to each other. I think below that, there's an interesting point as well, which is the LLMs themselves are available, cross-platform. So we're working on an Azure project at the moment, and actually we're using ChatGPT as the LLM within Azure. So there's a lot of kind of collaboration that goes on between, the big providers of these cloud platforms and these big LLMs. So what we did here, because we use Amazon a lot as well as we use IBM, is we just set this up on Amazon so that Amazon and IBM can talk to each other. And the web interface that Jala showed you is presented through Amazon. It's an AWS interface. And I won't go through the detail, but fundamentally, the SPSS user down at the bottom gets a page. We use a lot of JavaScript. It doesn't have to be JavaScript. It could be Python. It could be whatever, your tech team uses in-house or your tech providers use. It could be any particular kind of technology that just allows you to build websites and host databases. The Milvus database sits on our Amazon, so Watson is talking when it creates the vector database that Jarlath talked about. It's created within Milvus on Amazon. And there's a flow that goes back and forth into IBM from Amazon. Every time you ask a question on ChatSPSS, it goes back to IBM. IBM queries the database and it sends the response back to us. So it looks like a very technical architecture, but we very happy to talk to you about what might fit in terms of your setup. But at this moment, there probably will be code, but that's just it's a role where in order to deploy something that's quite technical, you need to step this way. The good news is to get to the point before deployment where you have a good performing model, you don't have to produce code. Thanks, John.
Okay, thanks, John. Thanks very much. So just as a summary, when it comes to working with us, if you're ready to start your RAG journey, your retrieval augmented generation journey, you should be aware that we can assist with every aspect of your RAG project. And that includes helping the solution design, selecting the appropriate tools and components. And as experts in data science and AI, we would normally take the approach of working with you on a project, maybe starting off with a little POC or something like that, a little proof of concept, just try it out. But the goal would be to try and work with you so that we would teach you how to do this yourself, so that once you got a version one set up, that would be you'd be empowered and knowledgeable enough to be able to go off and do your version two and manage and maintain that solution yourself. So offering skills transfer consulting is something that we would normally do anyway, but collaborating with your internal resources to deliver a complete solution that you own and offer, generally just offering advice and guidance on engineering, content selection, and all things related to RAG projects is something that we're happy to do. Other things you should be aware of is that we are a provider of SPSS technology. You can source your analytical software often from us with discounts, and we can assist with the selection, pilot, and implementation of analytical tools. We even have our own web store, but more generally, we offer formal classroom virtual training around the SPSS product line, as well as online self-paced training resources, which are freely available to our customers. But generally speaking, we offer no strings attached technical and business advice related to all things analytics and AI, as well as technical support services around the IBM SPSS product line. I do hope that you found that useful. Bear in mind that there is a recording available if you want to look at it again. And bear in mind that if there are colleagues that weren't able to attend today and you think it may be useful for them, do speak to them about it, and we will see if it's relevant and if it's useful for them. We can explore the possibility that we'll rerun this session on a private basis. In the meantime, thank you very much for logging in, and we look forward to you logging in again in the future. Thank you.